Good morning. Now we are discussing about the elastic limit. It is experimentally observed that for many substances, stress is directly proportional to the strain. When the stress is gradually increased, strain also increases, and a stage is reached where the relationship between stress and strain will no more be valid. So below that range, stress will be directly proportional to strain. Once that stage is reached, stress will be no longer valid related to strain. And this maximum value of stress above which there is no linear relationship between stress and strain is called elastic limit. In the sense, elastic limit is the limit below which stress is directly proportional to strain, and above it there is no linear relationship between stress and strain. In the sense, stress is not directly proportional to strain beyond that limit called elastic limit. Or in other words, below the elastic limit, stress is directly proportional to strain. In the sense, once the external force is removed, the body regains its original shape and size below elastic limit. And above elastic limit, since stress is not directly proportional to strain, once the external force is removed, the body will not regain its shape and size completely. And this relationship was first observed by Robert Hooke in 1679, and so this relation is known as the Hooke's law. And this is the Hooke's law. Within elastic limit, stress is directly proportional to strain. Or in other words, stress by strain is a constant, and that constant is termed as modulus of elasticity. And this modulus of elasticity completely depends on the material of the body. The dimensional formula of modulus of elasticity is m power 1, L power minus 1, T power minus 2, and the unit used to measure the modulus of elasticity is Newton per meter square. Now coming to the stress-strain diagram. Let us consider a wire fixed at one end and loaded at the free end. Now, because of the load, the wire will be extended. Because of the load. So you can see here, this is the original length, and there is an extension because of the addition of load. There is an extension. As the load is gradually increased, the elongation of the wire also increases. Load is nothing but stress, and the elongation is nothing but strain. So, stress is directly proportional to strain. If we increase the stress, strain will also increase, and that is shown in the graph over here by taking stress versus strain. From O to A, stress will be directly proportional to strain. In the sense, from O to A, the wire obeys Hooke's law. In the sense, if stress is removed, the wire will regain its original shape and size when stress is between O and A. If the wire is loaded beyond A, the extension the extension of the wire is no longer proportional to the load. In the sense, stress is no longer proportional to strain beyond A. In the sense, Hooke's law is not obeyed. Hooke's law is not valid otherwise. And if the load is removed beyond A, the wire will not regain its original length. And the elongation produced will be permanent. And at this point B, even an addition of small amount of load will result in enormous elongation. And this point B is called the yield point. And point A is called that we have studied here. Point A is called the elastic limit. Point A is called the elastic limit. Point B is called the yield point, because a small amount of increase in load results in enormous elongation at B. And this enormous elongation depends on the time for which the load is acting. Longer the time the load is kept, larger will be the elongation. Right? The specimen exhibits a phenomenon known as necking. That is, as extension increases, area of cross section of the wire decreases until the breaking point C, and finally the wire breaks. Necking is nothing but as the extension of the wire increases, as the length of the wire increases due to loading, the area of cross section, in the sense the radius of the wire decreases. In the sense, the wire becomes more and more thin until it reaches point C, called breaking point. And once it reaches the breaking point, the wire will break. The ratio of breaking load to the original cross-sectional area is called breaking stress. The ratio of breaking load applied to the wire such that the wire gets broken is called breaking load, and the original area of cross-section, that is pi r square, is called breaking stress. And this is called the ultimate strength or tensile strength of the material of the wire, called ultimate strength or tensile strength. This is about the stress strain diagram. Thank you.